Okay, 3.5, we do derivative of trigonometric functions. Let me write that. All right. Let me start with the formula first. Theorem 3.8. Let me see. The derivative of sine x and cosine x. Okay. All right. So then we do d over dx sine x. We get cosine x. If we derivative cosine x, then we get negative sine x. Okay. So let me show you this one first. Sine x, not the first. I'm gonna just do that. All right. All right, so we're going to use the definition, limit definition, sine x. Okay, then we do derivative about the function, then we are using h, right? So we do limit h approach to 0, sine x plus h minus sine x over h. Okay, so we are using this definition. All right, then let me make a note. So from trig course, we have, let me write down here, sine a plus b is a sum of sine. Then we have a sine a cosine b plus cosine a sine b. Okay, we learned this one from trig course, trigonometric course. So then look, this is the sum of sine functions. So we're going to use the formula. So that is sine A. So sine x, cosine B, cosine H plus cosine A. So cosine X, sine B, which is sine H. All right. And negative sine X over H. Okay. Now we're gonna switch that. The last term with the second term. Oops, I said the switching. I did not. So negative sine x and plus cosine x sine h. Over h, right? Now, we do make split the fraction this way. Limit h approach to 0, sine x cosine h minus sine x over h and plus, how about this? Since we had experience, let us make this way, okay? Sine h over h, right? Then what they have common in the first fraction which is sine x, right? So let us make factor out. X, missing x. My bad. Cosine x minus 1 over h, right? And plus, now, can you recognize this one?
You apply the limit rules?
Excellent. So let me just write down this one. How about here? So that we can save the time. All right. What do you get this one? Let me see. It's 1, so no space. Hold on 1 second. Sinx. Okay, how about let us clarify the first term. So sine x cosine xh minus 1 over h. Okay, so let me make this one. Okay. I don't know what to do because no space. How about erase it here? All right. Sorry about that. Okay. I'm struggling. How about we need to clarify this one first. Okay. All right. So this one, we can get a 0. Okay. Let me show you this graph. Okay. Let me just show you by graph. Okay. We can use conjugate method to show it's 0. Okay. Not good. All right. So when h approaches to 0, okay, so we get 0 for this one. Sorry about that, no space. Let me erase. Okay, and your classmate say that there is one rule, right? Equal to 1, right? So we have to know this one. Didn't we do this one too? last time when we introduce same limit, like limit h approach to 0, sine h over h equal to 1, and also limit h approach to 0, cosine x h minus 1 over h, right? So we are using conjugate technique to show that, right? So it's 0. Now, if this is 0, so I'm using this way because to save the space and work. Sin x. Then we say that this one is 0, right? Can you see that? And we have a limit h approach to 0, sine h over h, which is 1. So we get cosine x. Can you see? Okay. Then we can see that this is cosine x. That's why we have a derivative of sine x is cosine x. All right. Then we do similar processing. Then we get derivative of cosine, which is negative sine x. Okay. Now, let us do example. Let me erase. Okay. Find the derivative of, let me write down h of x equal to 5x cubed sine x. Okay, how do you find the derivative of the function? Does anyone knows what kind of rule we have to use?
Use the product rule.
Product rule, excellent. So we do f h prime over x, but then actually product rule, right? So we consider this is f, this is g, which is f prime g plus f g prime, right? All right. F prime, what do you get?
(15x squared).
Good, 15x squared. G, which is sine x, plus f, which is 5x cubed. G prime sine derivative of sine x, which is cosine x. We just did that. Okay, this is the first example. So I do for you almost. Okay, so second one. We have k over x equal to cosine x over 4x squared. How do derivative of the function?
The quotient rule.
Quotient rule, good. So if we have this is f over g, then f prime g minus f g prime over g squared, right? Now, f prime, what do you get? We just learned it's negative sine x, g, which is 4x squared. Be careful, this is not the function inside the composite function, right? So how about this? I want to write down 4x squared in front, right? Because I don't want to multiply x with 4x squared. So once again, f prime, which is cosine x prime, we get negative sine x. Then g, which is 4x squared, because I don't want to multiply with the x with the 4x squared, okay? Minus f, which is cosine x. G prime, what do you get?
8x.
8x, good. Once again, make it bigger. So you can then multiply with x and 8x over g squared, okay? Then this is a 4x squared to the squared, right? Let us simplify, okay? This is not subtraction, this is negative sign, right? So negative 4x squared sine x and minus 8x cosine x, because I don't want to multiply with x over 4 squared, what do you get?
16
16 and x to the how many power?
to the 4th power.
Thank you. So it's good, right? All right, let me erase this one. Okay, let's see. Number 3. So find the derivative of HK. What else we are using it? R over X. Thank you. Derivative. Derivative over x equal to 10x. Okay, so 10x. We just learned what's the derivative of sine x? That is cosine x, right? What is the derivative of cosine x? And that is negative sine x. Now, how do we derivative the tangent x, right? Then let's make 10x equal to trig identity. What is this?
Sine x over cosine x.
Excellent. Sine over cosine x, right? Good. Now we can make a quotient this one, so we can do quotient rules, which is f over g. That is f prime g minus f g prime over g squared, right? So then that is, let's make r prime over x. F prime, what do you get?
Cosine x.
Cosine x, good. G, which is cosine x, minus f, which is sine x. G prime, what do you get?
negative sine x.
Negative sine x. Now, over g squared, which is cosine x squared, right? Now, this is cosine square x minus, and then there's another minus, so plus sine square x over cosine x squared, okay? So we should know this one. Cosine x squared is the same as cosine square x, all right? Now, what can you see this one? You cannot see? Then let me make a note. Pythagorean identity, which is cosine square x plus sine square x, which is what?
1.
Excellent. Okay, so each one over cosine square x. Okay. All right. Look, I just said that cosine x parenthesis square is the same as cosine square x, right? Then do you agree this one? Like that. Do you agree?
Yes.
Okay, good. Now, what's the 1 over cosine x?
Secant.
Secant, yeah.
Okay, so it's a secant. Okay, then this is the same as a secant square x. Is okay?
Yeah.
Okay, good. Let me erase. All right, then we have other trigonometric function, okay? So derivatives, let me make a right spell. Tangent x, cotangent x, secant x, and cosecant x. Okay, so derivative over 10x, we just did secant square x. Now, we derivative cotangent x, then we get negative cosecant square x. Okay, then we do derivative secant x, then secant x, 10x. Now we derivative cosecant x, then negative cosecant x, oops, cotangent x. All right, so please remember this one. We're gonna use a lot, okay? Entire semester, summer section, and also for Calculus 2, and also a little bit 3, okay? Because Calculus 3 we are using derivative, also integrals, okay? And Calculus 2 as well. Please remember this one. So derivative, we did all the rules, right? We must remember. And then derivative for trigonometric function as well. This is 10 stars, more than 5 stars, all right? All right, so this is find the equation of a tangent line tangent line better. Line tangent. Tangent line. To the graph. Cotangent x at x equal to pi over 4. Okay, so we did this one so many times, right? So what is the first step? Oh, scare me.
That was a pretty good one.
Right? This earthquake?
Yeah, that was an earthquake.
Scare me.
Yeah, it was.
Oh.
It's still kind of shaking in my house.
Wow, you see, I thought it was upstairs making, noise. Oh, scare me. Oh. Wow. Okay, so let's go back, find the equation of a tangent line to the graph, okay? So what is the first step?
Find the derivative of f of x.
Yeah, so we're gonna find what is f prime of x. So we just learned what's the derivative of cotangent x?
Negative cosecant squared x.
Excellent, right? Now, we want to know about when the pi over 4, right? Now, this means the same as, okay? What's the cosecant? Oops. We need to think cosecant pi over 4 first. Then we do square them, okay? Cosecant pi over 4. So what is the cosecant? How do we express with the other trig function?
1 over sine.
1 over sine. 1
And
over
I believe,
sine. Pi over 4.
yeah. And then, yeah, bracket squared.
Thank you. So what is the sine pi over 4?
I might be wrong, but I think it's square root of 2 over 2. Am I wrong?
So but then it's the denominator, right? So it's the same as actually square root 2 over 2. So we have 2 square root of 2, right? This is same 1 over square root of 2. Is it? Can you check that this one?
I think that's -2. I think it's -2.
This is square root of 2. So let us just do that. Square root of 2 over 2. You said that?
Yeah, and then
And then we do
then you
reciprocal. So minus, we get 4 over 2, which is -2, right? It's okay?
I think it's -1/2. But I could be wrong. I just put it in my calculator.
Uh,
Yeah, I think it's
You
negative
you
2.
just give it to me square root 2 over 2, right? So I'm using that.
Okay.
No, that's right.
Okay. Yeah. So original. I didn't use the original number. Okay. So
Okay.
I was using just whatever in the chart. I was using that. Okay. Is okay?
Mhm.
All right, then we're not done yet. We're gonna find the equation of the tangent line. So we are going to use the what is called slope point, right? Point slope formula. So y minus y sub 1 equal to slope. So in this case, that and x minus x sub 1. Okay. So when x equal to pi over 4, so cotangent pi over 4, what do you get? Okay, how about tangent pi over 4 then?
I have a question. In this case, would negative 2 be the amplitude?
Okay, don't say that.
Uh,
Don't say that.
okay.
Okay, pi over 4, what do you get?
Is it 1?
Is it 1? It's same as tangent, right? So tangent pi over 4. So we have a pi over 4. Then we get 1. Okay, so y minus y sub 1, which is 1. The slope, which is negative 2. X minus x sub 1, which is pi over 4, right? All right. So then y minus 1 equal to negative 2x and plus we get positive pi over 2. Okay. Then what do you get this one? Let me see. We get y equal to negative 2x plus pi over 2 plus 1. Okay. Just a real number. Is okay? Yes or no? We did so many times to find the equation of a tangent line, but at this time it's just trig function, one of a trig function. Is okay? Yes or no? Let me erase. Okay. All right. Let us do find the derivative of f of x equal to cosecant x plus 10x 10x. All right. Okay, so with derivative, we need to figure out how many terms there. How many terms there? Hello? Two terms, okay? Okay, two terms, so we do term by term, okay? So we derivative, first term, what do you get? We derivative of cosecant x. Derivative of cosecant x. I want to remember this. I will keep asking you over and over and over and over and over and over. What's the derivative of cosecant x?
Negative cosecant x cotangent of x.
Negative cosecant x, cotangent x, good. Now, second term is the product, right? So we're gonna use a product rule. So let's just say that this f, this is g, which is f prime g plus f g prime, right? Okay, f prime, what do you get? Plus 1, good. Then g, which is 10x, okay? But in multiplication, we don't have to write down 1, right? But in the beginning, we have to get used to it. That's why I'm writing 1 here, okay? Then plus f, which is x, and g prime, which is, what's the derivative of tangent x? Tan x, derivative of tan x?
Secant squared x.
Secant square x, good. All right, so just leave it like that. Cosecant is one of sine. Oh, we can simplify here. Can you see? Oh, no, cannot. Because cotangent. I thought sine over cosine. Okay, then. Let me erase 1 there. So we don't have to carry one more step. All right? So this is that. All right. Let us do this one. Like your homework, right? First. Find the first 4 derivatives of y equal to sine x. Okay, so y prime, we denote. So what's the derivative of a sine x?
Cosine x.
It's cosine x. Now, what's the second derivative?
Negative sine x.
Good. Now, what is the third derivative?
Negative cosine x.
Good. What's the, okay, now from now on, we're gonna write down this one because too many. People cannot count. So what do you get?
Back to sin x.
Yeah, it's the positive sin x. We're going back, right? So like a fifth, then do again, right? Going back, cosine x, right? So we do fifths, right? Then we do 6, right? We do 7, we do 8, right? And then do again, right? Let me erase this one. Okay, so let us practice more. Derivative of, okay, number 1, let's get started. All the time, cosecant x plus 5 over x. How many terms there?
Two.
2. So we do derivative term by term. So what is the derivative of 3 cosecant x?
-3 cosecant cotangent x.
So -3 cotangent, cosecant cotangent. Good. We did that earlier, right? What about second term? How do we do? Does anyone has idea?
You can use the power rule.
Excellent. So this is a better using power rule, right? Rather than quotient rule, right? So then what do you get?
5x to the negative second power.
So -5x to the -3 second power. Okay. So this is -5 over x squared. Okay. Very good. Okay. Question? Did I make a mistake? All right. How about x over 1 minus secant x? What are you gonna do this one?
Maybe we can turn tangent and secant into their other, like how tangent is sine over cosine, and then might be wrong about what secant is, but I think it's 1 over cosine or something like that.
But that's too complicated.
Too complicated.
Yeah. Thank you for your thought, though. Good try. We do try, okay? We don't know right away, okay? So how can we use other method instead of that? What we are doing here,
Just use the quotient rule.
excellent, we're gonna use the quotient rule, right? So because we need to find the h prime of x, right? So f over g, f prime of g minus f g prime over g squared, okay? All right. Yes, then f prime, what do you get? What's the derivative of a tangent x?
Secant squared x.
Secant square x, good. So we have a secant square x. G, which is 1 minus secant x, minus f, which is 10x. G prime, what do you get? G prime,
Secant x, tangent x.
secant x, 10x. But then we have a negative sign, so negative secant x, 10x, right? All over g squared. Okay, then we cannot simplify, huh? So I think your homework just to write down, just simplify a little bit, not too much, right? Simplify just this much, right? All right. It's okay. Okay, let me erase. Number 3. You want my sin x. How do we do this one? How do we start? Product rule, good. So product rule, which is f. This is the holding f. This is the holding g, which is f prime g my plus f g prime. Okay. All right. So k prime of x F prime, what do you get?
One minus sine x.
Excellent. Okay, so we do term by term, so it's a 1 minus sine x. Now, g, which is 1 minus sine x, and plus f, which is x plus cosine x. Now, g prime, which is 1 minus sine x. With derivative, 1 minus sine x, what do you get?
Negative cosine x.
Negative cosine x, good. So we have a negative cosine x. Okay, then we have 1 minus sine x, quantity squared, and let us make plus x minus cosine x and minus cosine square x. We can label like that, right? Or you can take out the addition here, right? Okay, so any question about, hold on 1 second.